Today we're going to be looking at the Unit 2 review. Now in Unit 2 we were dealing with various displays of data that we've collected from the Unit 1 types of sampling methods. For the first bit, it says for numbers 1 through 4, the data shown represents a percent chance of rain on a given date in 12 different cities. The first one, we're going to make a dot plot using that number line and that information. Remember, dot plot is the display where we just put a dot above the number. So we have 60, so put a dot above it. 67, a dot. 80, and another 80. So we stack the dots. Then we have a 73, 85, 87, 75, 85, so we stack again, a 90, 95, and a 100. There is our dot plot. The second one wants us to make a histogram. Now the issue is we just have what they're calling intervals. The intervals are what we called in class as our class limit. The number of values is our frequency. So we are missing the class boundary, which we'll deal with in a moment. So we're going to look at our set of numbers again and see how many numbers are between 60 and 69. Looking at our list of numbers, only 60 and 67, so our number of values is 2. 70 to 79, we have 2 again, so 73 and 75. 80 to 89, we have 5. See 80, 80, 85, 87, and 85 again. 90 to 99, we have 3, we have the 90, 2, we have the 90 and 95. And then the 100 to 109, we have 1, just the 100. So remember, we need to find our boundaries. For our boundaries, we subtract 0.5 from our lower limit, add 0.5 to our upper limit. So the 60 to 69 becomes 59.5 to 69.5. I will move this over here so we can see it a little bit better. The 70 to 79 becomes 69.5 to 79.5. We have 79.5 to 89.5. 89.5 to 99.5. Lastly, we have 99.5 to 109.5. So we're going to make our histogram. We need our bar graph, our L graph, okay. Remember, we're going to label our y-axis, one going up and down, as frequency. Going up and down is frequency. And going left to right is our boundary. Our highest frequency is 5. I want to make sure we have at least 5 hash marks. Trying to keep the same distance between each of them. And then our boundaries. We have mark here, that would be our 59.5. There is 69.5. Keeping the same width. We have 79.5. Same width. 89.5. Same width. 99.5. Same width. 109.5. So next we draw in our bars. First one was 2, so we go up to 2. Draw in a bar, back down. Next frequency was 2. We're gonna have our bar, go back down. Then we have 5, up to 5, on a bar, back down. Then we have 2, draw in a bar, go back down. And then we have 1, bar, back down. So remember, a histogram does not have spaces between the bars. Last but not least, we need to create our box plot. So we need to find our 5-number summary, which is at minimum quartile 1, median quartile 3, and maximum. So we need to type the numbers into our calculator. Well, I will pull up the calculator. So remember, we hit stat on our calculator, and we want to hit enter for the first one. If we have numbers in, we move up, hit clear, then we move down. Then we start entering our numbers. Making sure to hit enter after each one. So we have 60, enter, 67, enter, 80, enter, another 80, enter, 73, enter, 85, enter, 87, enter, 75, enter, 85, enter, 90, enter, 95, enter, 100, enter. Our next thing that we have to do, second mode to quit out, hit stat, move over, hit enter. And if you're using the physical calculator, you want to hit enter, otherwise you go down to calculate. And there is our information. To get our 5-number summary, we scroll down. So here it is. So our 5-number summary in this problem smallish for right now is going to be 60 for our min. Quartile 1 is 74. Median is 82.5. Quartile 3 is 88.5. And maximum is 100. So we're going to draw a bar above each of these numbers of 60, of roughly where 74 is, above 82.5, 88.5, and 100. Make our box by combining Q1 to Q3, and then draw in our whiskers. A couple things that we do need to know. First, for a dot plot, a histogram, and a box plot you created, compare and contrast which key features can be seen from the representations. Meaning, what does a dot plot tell you? What does a box plot tell you? What does a histogram tell you? Now, this is an example of what we could write. So, the dot plot and box plot show exact minimum and maximum. Box plots shows the median, but not the mean. Dot plots show the gaps in the data, and all three show gaps in the distribution. Histograms show the distribution. So keep in mind, if a problem asks for us to have a display that shows gaps in just the data, dot plot will have to be our information or our display. Otherwise, we could use any of them if we just want to see gaps in distribution. Moving on. Says, for number 5 through 6, use the word bank to identify an appropriate representation for the given situation. Explain your choice. It is important to say your explanation. That is, as a heads up, a single point on your assessment. So for number 5, you randomly survey 30 restaurants and keep track of the number of people entering every 15 minutes for an hour. You would like to display this data so that gaps in the data are visible. So there are a couple things that we first need to figure out. First, we need to figure out if our variable is a qualitative variable or a quantitative variable. Since we're keeping track of the number of people entering, that makes it quantitative. Because it's quantitative, I know I cannot use a bar graph, and I cannot use a pie chart. So, we want to have a display that shows gaps in the data. Oh, I actually just said that. So that would be our dot plot. Our explanation would be quantitative variable that shows gaps in data. For number 6, we would like to display the favorite types of classes students have. On surveying the students, they were told they could list as many choices as they had. So once again, we need to figure out a variable. Since they're responding with words, that is a qualitative variable. Meaning, we cannot use a histogram, a dot plot, or a box plot. We only have options of a bar graph or a pie chart. Because it says they could list as many choices as they had, it has to be a pie chart. I'm sorry, a bar graph. A pie chart, you can only have one response. Because remember, a pie chart has to have up to 100%. Cannot be more than 100%, cannot be less than. If we let people respond with more than one thing, that's more than 100%. So your explanation would be it's a qualitative variable, and they could list as many choices as they had. For number 7, the data below represents the ages of people entering high V. So this is going to be, once again, entering the numbers in the calculator. Use your calculator cheat sheet to do this. So after entering the numbers in, and you hit the second mode to print out, then you hit stat, move over, hit enter, and hit enter again. It will give you a list of things. Remember, your mean is your X bar, which in this problem is roughly 49.0789. I'm going to go out to 4 values after the decimal. The more we have, the more accurate we will be. Standard deviation in the calculator is your SX, or in this problem, 24.0353. We scroll down to find our minimum, which is 3. Our Q1, which is 35. Our median, which is 47. Our Q3, 65. Maximum, 107. All of that is on your calculator. Interquartile range, or IQR. Remember, is our Q3 minus our Q1. So in this case, it is 65 minus 35 to get 30. Now for outliers, there's a process. We're going to take that IQR times 1.5. It will always be 1.5. 30 times 1.5 gets us 45. And there are 2 things we're going to do. We're going to take our Q1. We're going to take the 35 minus that 45. Doing so, we get negative 10. And we look at our numbers. According to our numbers, we have no number smaller than negative 10. So we have no lower outlier. We're going to take our Q3, 65, and add the number we got. So 65 plus 45 gets us 110. Looking at our numbers, we have no number larger than 110. So we have no upper, meaning we have no outliers. Moving on. Number 8, for the histogram to the right, determine if the mean for this distribution will be closer to the mark A or the mark B. Explain how we know. So, in order to do this, we have a histogram. We need to figure out our distribution. So is this normal or mound shaped, where it's balanced on both sides? Is it skewed left, where it looks like it is a slide going down to the left? Or is it skewed right, where it looks like it's a slide going down to the right? If the distribution is mound shaped or normal, whichever letters in the center is our mean. But our skewed pulls the mean in the type of way it is. So this one looks like a slide going down to the right. So because it's a skewed right, it has to be letter B. It has to be letter B because B is the one farther on the right. If it was skewed left, we'd go with A because it would be on the left. So be careful. Number 9, the box plots below display the distributions of hours of sleep students in DCSD, or of students in DCSD, separated by the day of the week. Compare the distributions from each day in context of using shape, center, spread, and outliers. So there are 4 things we are going to need to say. So first, let's say shape. Shape is referring to the distribution. Now these might be a little bit harder to see when we say skewed left, skewed right, and whatnot. But we can kind of use our median to help. So if you look at Monday, you have a very high median, a lot more data is below it, so that is skewed left. Looking ahead, Wednesday is also skewed left because we have a lot of data there. However, on Thursday, because of that tail, it is not going to be as skewed. It kind of looks like it. If you want to say it's skewed, we wouldn't count it against you. However, looking at it, Monday, Wednesday, and Sunday are skewed. So that's what we'll put. Monday, Tuesday, I've had Monday, Wednesday, and Sunday, are skewed, and because more of the information is below it, that would actually be skewed left. Center. Because these are box plots, the center of our graphs are called the median. So looking at it, let's see what's the highest median, what's the lowest median. It looks like Friday has the highest median. And it's kind of a toss-up between Wednesday and Thursday, but maybe Thursday is a little bit lower. So we'll say Friday, largest median. And Thursday, lowest median. Spread. So spread is going from one bar to the other bar. So we're looking for the largest grouping. it looks like Monday could be close, but going farther down, it does look like Saturday beats them all out. So for spread, once again, Saturday has largest range. And then outliers. On this graph, the outliers are these dots. Looking at it, we have one dot. We have a large outlier on Tuesday and one on Sunday. I might put that. So we have uppers on Tuesday and Sunday. And we have lower, looks like on Thursday and on Friday. Okay. On your assessment, please make sure you do answer each of those 4 parts. Last set of questions. For 10 through 12, the data below shows the time in seconds for members of Derby cars at a Club Scout event. Now, 10 does say choose and create an appropriate display to represent this data. So, our data is numbers, it is quantitative. So, you have options. We could make a bar graph. Well, we could not make a bar graph, we could not make a pie chart. Those are qualitative. Meaning, we could make a box plot, we could make a dot plot, we could make even a histogram if we wanted to. This is going to be up to you. So, we could make a dot plot, go from our smallest number, looks like the 265, to our largest number, which looks like it's the 485. Put dots above the numbers. We could type the numbers in our calculator, get our quartiles, and make a box plot. We could type in the numbers on our calculator and do stuff for the histogram. Once again, this is up to you. Because of that, we're not going to really go through this one now. This is your choice. So it's going to be make a box plot, or histogram, or a dot plot. It all depends on what you feel more comfortable with. As for the explanation of what the data you created tells you about the Derby cars, keep in mind, this goes back to the very front page. Dot plots tell you the minimum and maximum, as well as gaps in the data. Histogram shows you the display or the distribution of the information. Also, a box plot shows you the maximum and minimum, as well as the median. So depending on what you make, state what you used. State what it helped you find. Once again, refer back to the front page bottom question. Finally, 12. Would the mean or median be a more appropriate measure of the center of this data? This, again, is dependent on your display. Typically, if you use a histogram, a mean might be more accurate for the center. If you use a box plot, the median is already in the center, so we would use a median. Besides, a mean is not shown at all in a box plot. As for a dot plot, either would really work. For the dot plot, it looks more like a histogram, so we could say mean. However, because it is shown in order from smallest number to biggest number, we could say median. No matter which one you choose, the biggest point of this question is to defend your choice. Don't just say median or don't just say mean. Why are you saying that?